chapter 2. Alright, so I know some of you have attempted Mastering Physics, chapter 2. Some of you have not, but that's what we're going to do today. Chapter 2, not Mastering Physics, but chapter 2. All right, so we're on page 42. So you should have your book out and you can follow along. All right. Somebody want to read first problem on page 43 under speed and velocity? These are under the problems, chapter 2. Nobody got it yet? So nobody got it yet? What's the problem?
Nothing's loading on my, that's fine. I'm just gonna try.
So I mentioned to you in the beginning of the semester that you should download your textbook to your machine. That way, there's no need to log in to anything. Your textbook should be on your machine. So now we're gonna waste like 15 minutes waiting for y'all to log in. And then when we get to the end, you know what y'all gonna say? What can I do to help my grade? And you know what I'm gonna say? Nothing. What you got? Huh?
That's accurate.
Go ahead.
What page is it on?
43.
If you are driving 95 kilometers an hour along a straight road and you look to the side for 2 seconds, how far do you travel during this inattentive period?
All right. So, we have a set of problem-solving strategies, right? We covered that in the lecture notes, right? So we're gonna walk through that strategy real quick on this problem right here. Okay? So first step is to read the problem and understand the question. So what is the question?
If you're driving 95 kilometers an hour.
No, you don't have to read, you don't have to,
How?
just tell me, just talk to me. Talk to me in regular language. I asked you a question, just answer my question. Say, what's the question? What is the problem? What are we trying to solve for? What are we doing?
How far you travel?
So we're looking for a
Distance.
distance. So distance. We normally denote distance with x, right? Okay? That's the first step. To identify, well, read the question, understand the question, and, well, understanding the question is identifying the problem. Well, you know, understanding what the question is asking, right? Okay? And that's very important because sometimes, you know, like I said, problems in physics are a bunch of steps, and sometimes you can get lost and forget what you're trying to solve for. All right? So the next step is the givens, right? And let me make sure, for some reason, I think I'm skipping a step. Let me just make sure right quick. I should remember this, but I have so many things on my mind. Lecture. Physics resource, there we go. Yeah, I think there might be one step. Can't quite remember what it was. There it is. Here we go. Okay. So, actually, yeah, I guess this is important. I should say this too, right? So, the next step, right, is to decide what time interval we're under, right? So what that means is, are we talking years, seconds, days, whatever, right? So here we're talking what? Seconds. All right, that's the time interval. And that's also important, right? Because it goes to whether your answer makes sense or not, right? Because if I calculate something and I notice that, oh, okay, well, I'm driving in the car and I look to the side for 2 seconds, right? Or in this case, it's telling you the time, right? In some cases, it's going to ask you to calculate the time, but it's going to give you another unit that has a time interval in it, or a time unit in it, and you can still determine what the time interval is using that unit. All right, but you need to decide on the time unit, because if you know well, in this part, the example I was gonna make in this case, it won't work because they told you the time already, right? But you'll see, right? We'll have plenty of instances where we calculate time, and we might be talking about a asteroid or a planet or something like that, right? And whatever time you calculate, it has to make sense. It has to coincide with on what time frame would that object move, right? Like light, for instance, right? If we're talking about years with light, then we know that's a long distance, right? But a lot of times when we talk about speed of light, we talk about it in what? Meters per second. Okay? So that's important. Number 3, next step is to draw a diagram, right? In this case, we might not need to draw a diagram, okay? Because we can visualize this in our head. Draw a diagram. Okay, we can visualize what's happening in this problem in our head. If we're driving in the car right? And we're driving in a straight line, we look to the side for 2 seconds, and we wanna know how far did we travel in that, right? When you're looking down at your cell phone, right, read the text message, you wanna know, you traveling at 95 kilometers per hour, how far do you move in that time period, right? So, 4 is givens, all right? So, what tends to happen is what we do. So, a lot of times we don't even do this step. We don't even do this step. That's based on my experience, right? I'm telling y'all, most people don't even do this step. What step do they skip to? Givens. 4. Right? Because they're so quick to do what? Some math, some equations, before we have understanding of what's happening. That's the first thing. We need to have understanding of the situation, because all of these are little situations. Every problem you read is a little soap opera. And you have to treat it like that. That it has little nuances in each one, right? That make one different from the other. Okay? So, now we have to get it. There you go. Shit, I've been waiting on that. Yeah. So now what's the givens?
95 kilometers an hour.
What is 95 kilometers per hour?
Speed.
It's a speed, right? Or the rate you're going. Yeah, you want to say that? Rate you're moving, right? So speed. You said 95 kilometers per hour. What else? So we have a time of 2 seconds. What else?
Rotary Street.
Huh?
The Rotary Street?
I didn't hear you.
I said, I don't see nothing else with the Rotary Street.
Okay, well, no, that's it. If you don't see nothing else, there's nothing else. All right? Now, we have to do what? So now we know the givens. Now what we gotta do? Huh? Well, yeah, well, in terms of the problem solving strategy, what's the next step? Is to look at the what? The equation. What equation are we gonna use? The physics. What people call physics, right? So step 5 is what's the physics? What's the equation? That's all that is. What's the equation we're gonna use to solve the problem? So here, what are we gonna use? What equation are we gonna use?
The average speed equals distance over time.
All right. So, what is it? Giovanni?
Gianna.
Gian. Let's say average speed equals what? Distance over time. Right? And we are looking for what?
X.
We're looking for X. Right? So then we're gonna rearrange this equation, and what we're gonna get? X is equal to what?
B times T.
V times T. Right? And so V is what? 95 kilometers per hour. T is what? 2 seconds. Right? So we know we can't multiply these two together, right? We have 2 different units of time. So we either have to convert 2 seconds to hours or 95 kilometers per hour to kilometers per second.
Seconds to an hour.
Seconds to an hour? All right. What you got? Well, I ain't gonna write it. I'm gonna let y'all do it. You just tell me what it is, and we can argue about it if we don't agree. So how many people in here are challenged with algebra? Okay.
I got 5.55 e to the negative 4.
5.5 times 10 to the negative 4
Yeah.
hours.
Hours.
Everybody agree with that?
Yes.
You got the same thing? All right. Well, that must be what it is. We're gonna roll with it till somebody say, I disagree. All right. I got no trash can. So now I just do what? I just put my number in the equation. 95 kilometer per hour times 5.5 times 10 to the minus 4 hours. Oh,
I got 5.28.
what is it?
5.28 times 10 to the negative second.
10 to the negative 2?
Yeah.
5.28 times 10 to the negative 2 kilometers per hour. Everybody agree with that?
I did 5.3.
Same
Oh,
thing.
yeah. This was just kilometers.
Oh, I'm sorry, kilometers. Yeah, we're looking for distance, you see that? See, that's why it's important to always go back to step 1. Okay? Yeah, we're looking for distance. So I see I didn't go back to step 1. All right? So that's our problem solving strategy. Well, let's do one more thing. All right, let's take it all the way. Okay? So, and that's well, actually we just did it, but we'll explain it. Okay? And the last step 6 is dimensional analysis, I think. Right? Dimensional analysis. Right? And that's what we just did, right? Where we said what? Kilometers per hour times hours. Get that and that, and we're gonna end up with kilometers, right? End up with kilometers. And those come from here, kilometers per hour and hour. Everybody following that? Okay, good. All right, so now, let's jump down to number 7. Somebody read number 7 for me? Anybody?
It says you were driving home from school steadily at 95 kilometers per hour for 118 kilometers. It then begins to rain and you slow to 65 kilometers per hour. You drive home after 4.5 hours. How far is your hometown from school and
What's the first step? We're looking for, well, yeah, that's one thing, right?
How far is your hometown from your school? Distance, average speed.
Yep. All right, so, you said we're looking for distance, right? Average speed. Right, so X and GR, right? All right, step 2. What's step 2?
Identify the nodes.
Oh,
That's good.
yeah. Time interval, right? So what type of time interval are we talking? Hours. Right? Why is it important to identify time? Anybody want to take a guess?
Depending on the object, you can always change. That we're talking about, or situation.
Well, no. Well, exactly the opposite of that. Regardless of the object, time never changes. You know what I'm saying?
Mm.
So it is the ultimate, right? That's why they call it what? Father time. Right? Time is everything. Okay? It's the ultimate independent variable when you're talking mathematics. All right? So, let's see. 3. What's 3? Step 3 is to do what? Diagram. Right? So we could draw, right? We could draw a little, right? A little car. And we could draw a little what? Right? Or maybe this is, maybe we're leaving the schoolhouse right here, right? And this is home right here, right? Maybe the school is over here somewhere. This is school. Right? And it says what? It says you go, you traveling, and then at some point, it starts to what? Rain. And you did what? Slow down. So you have what? 2 speeds. So I have a speed at the first. What was that speed at the first?
95.
I heard 2 different. I think I heard different things. Say it again. 95. So the first speed is 95 kilometers per hour. All right. And what else does it tell you about that? Doesn't it give you distance or something?
180 kilometers.
All right. So then that means that from here, let's say from here, right, to here is what? 180 kilometers. Okay? And then, right, the remainder of the trip, right, start raining. Blah, 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 right? Whatever. It's raining for the remaining of the trip, right? And that's where you slow down to what? 65 kilometers per hour. And what else do they tell you about that? Nothing?
You arrive home after 4.5 hours.
Okay,
driving.
so the total time takes what? 4.5 hours. So from here to here, it takes us what? 4.5 hours. Right? So from here to there, right? 4.5 hours. So we got everything? So now what? Got our little cartoon, right? Hmm?
Do your givens.
Okay. So for 4 is givens, right? What are they?
4.5 hours.
You gotta tell me what they are.
Distance is 180 kilometers.
The total distance?
Been driven 95 kilometers an hour.
Okay, so the first distance.
Yeah, first.
So let's call that x1, right? That's what? 180 kilometers. All right.
Then speed 1,
Speed 1,
95 kilometers an hour.
95 kilometers per hour.
Then speed 2,
Then speed 2,
65 kilometers an hour.
65.
Then total time being,
Total time.
yeah,
Total time is what? T1 plus
T2.
T2. And so we know that to equal what? 4.5 hours. Right? So now we have identified our givens, right? Yes. All right. So, because we slowed down, right, we got 2 speeds, we're just gonna treat this separately. Right? So we treat the first one as what? Because we already know that what? Distance or speed is what? Distance divided by time. That's from here to Timbuktu. Right? So we know that what? And I'm right over here. Right? We know that what? Speed is equal to distance over time. So then in the first part of the trip, we know we have what? What do we have in the givens for the first part of the trip? We have the speed and
The distance.
so we can calculate the time for the first part of the trip. Okay, so the time for the first part of the trip is what? T equals what? X divided by V. So that's what? 180 kilometers divided by 95 kilometers per hour, right? And we make sure with our dimensional analysis that the units match up so they can cancel out. That's dimensional analysis. All right, so whatever that result is, that is what? The time in hours. And what is that time?
1.89.
1.89, 1.9. It's all the same, 1.89. hours. So that says that what? For the first part of the trip, he drove for 1.89 hours. So T1 is what? 1.89 hours. So if I know T1 and I know T total, then I can find T2. So T2 is T total minus T1. 4.5 hours minus 1.89 hours. What'd that give us? 2.61 hours. So now, what does that mean?
And that's how long it took to drive 65 kilometers per hour.
Yes, that was the time that it took to cover the second part of the trip. It's important we say these things to ourselves after we get a result. I'm telling you this from experience. You have to say it to yourself. What did I just calculate? Because a lot of times, if you can't say it to yourself, then a lot of times, or when you say it to yourself and you're like, ugh, you say something don't sound right about that. A lot of times you're right. All right, so the second part of the trip took 2.61 hours. First part of the trip took 1.89. All right, so now for the second part of the trip, if we know the time, T2, and we know what?
Speed.
V2, then we can calculate
The distance.
X2. Y'all see how this works? These are puzzles. You have to be organized and you have to keep track of things. But it's really not that difficult. So, what is X2? X2 is what? X2 is what? V2 times what? T2, right? So we know that what? V2 is 65 kilometers per hour, and T2 is 2.61 hours. So now we have a value for T2, X2. What is it? 169 what?
0.65 kilometers an hour. I mean, just kilometers.
So I heard some people say kilometer per hour, right? And so you need to understand that, right? Kilometer per hour is a what? A speed. If I'm asking you for a distance, your final result can't be in kilometers per hour. That just doesn't make sense. So that's the first step, right? That's another part of step number 1. I forgot to mention that, right? When you identify what you're looking for, you can also identify what? Units. You can also identify the units that you're looking for. That's why we started with units. Okay? So that's the name of the ball game. It's units. So we got what? 169 kilometers. Right? So now what can we do?
Find the total distance.
Find the total distance. How we do that?
Distance 1 to distance 2.
X1 plus X2 gives you the total distance. Yes, indeed. So that's what? 180 plus 169. And what is that we just calculated?
So the cost
Huh?
the cost difference to get from school to home.
I couldn't hear you.
The total difference to get from school to home.
Yes. The total distance to get from school to home. We have to say these things out loud, y'all, to ourselves. I'm telling you, it helps you. So, I run out of room. So you right? What was it? Three? What is it? 180? 3, huh? 349. Everybody got? All right, 349 kilometers, right? And everybody see where we got that from, right?
Yeah.
180 plus 169. 349 kilometers. Now the second part of the trip said what? The second part of the question said what?
Find the average speed.
The average speed. So how we do that?
The average distance we just got divided by the total time.
That's one way. Hold on. Let me erase all of this. Okay. Oh, I shouldn't erase that part, huh? But, oh well. It's recorded. All right. So now, Gianna said that total distance, which was 3. So we're trying to get average speed, right? Average. Oh Lord, average. I forgot how to spell average. Average. All right, average speed, right, is equal to distance over time, right? And so we know the total distance is what? 349. And we know the total time is what? 4.5 hours. Now, what's the other way we can do this? Well, tell me what this answer is first.
7.75.
Say it again.
7.75.
7.75?
I think it's because it's
Scientific.
scientific, yeah.
Oh yeah, my fault. 7.75 to 1, but yeah, 77.5.
Okay.
I was
77.5. Now you see why y'all understand why I can hesitate and pause like that? Right? Because I know that we're talking about a vehicle that was traveling at 95 kilometers per hour at first, then at 65. So if I ask you, well, what was the average speed, and you say it was 7 miles per hour or 7 kilometers per hour, then I'm gonna say, what? They was traveling at 95, then at 65, and you telling me the average was 7? See, this is what I'm talking about when you get to a result, you gotta ask yourself, well, does that make sense? So does average speed of 7 make sense here? No, because we was at 95, then we slowed down to what? 65. So where should the average be? Between those two. Duh. So what's the other way we can solve for the average? We talked about it at the beginning.
Did you
Add the two speeds.
Add the two speeds and divide by 2. Right? Oh, this is what? 77.5 kilometers per hour, right? And let's see if it works out. What was it? 95 plus 65 is what? 0, 1. What's that? 160. 160, and then that's divided by what? 2, right? So when we talk about average, that's the whole point about average, right? Is that 77 and 80, same thing. Okay? Especially when we talking about big objects like a car. Now we were talking about electrons or maybe even cells. I don't know. I don't know how fast cells move, because I don't study cells. But maybe there's a cell that moves very fast over a short distance. Maybe there's a cell that doesn't over the cell's lifetime, it only needs to go from here to here over its whole lifetime. Right? And maybe it does that quickly. Right? Or we talk about what is it? Pulse, right? The pulse on your heartbeat and all that kind of stuff. Right? That has to do with speed. Believe it or not. Okay? So, this one, like I said, this one's gonna give you what, 80. Right around 80 kilometers per hour. But we're talking about average speed. So when we wanna get better accuracy, that's when you move into calculus. That was the point of us talking about the limit and all of that. And I told you, when you want more accuracy, you gotta use calculus as opposed to average. But we're using average in here, and that's gonna be good enough. All right? So, 12:45. So, all right, folks. So that was so what was that? That was like 2 problems. Okay. So, this is the level of detail. Well, we're just getting into that. We're just getting into this problem solving exercise. Okay? So by the time we get to chapter 4, we're going to have quite a bit of detail in our problem. All right? So, have a good weekend.